This is a video from section 6.5. The directions say to find the average value of the function on the given interval. We define the average value of f on the interval from a to b as. So I'm going to write f with the subscript of AVE, and that just stands for the average value of f. That equals 1 over b minus a times the integral from a to b of f of x dx. And what we're going to do is we're going to take a look at problem number 1, and this is in the Stewart Calculus textbook, 9th edition. Suppose f of x is equal to 3x squared plus 8x, and the interval is from -1 to 2. And so we're going to look at the average value of f, and that's going to be 1 over 2 minus -1, b minus a, times the integral from -1 to 2 of 3x squared plus 8x dx. And so this is 1/3 the integral from -1 to 2 of 3x squared plus 8x dx. And so this is 1/3 times the quantity. We get x cubed plus 4x squared, and we're going to evaluate from -1 up to 2. Now, this is equal to 1/3 times. We're going to plug 2 in for x, right? And we're going to get 2 to the third plus 4 times 2 squared. And then we're going to plug -1 in for x, and we're going to get -1 to the third plus 4 times -1 squared. Now, 4 times 4, 2 squared is 4, right? 4 times 4 is 16. 16 plus 8 is 24. So we get 24. And -1 squared is 1. 1 times 4 is 4. -1 cubed is -1, so 4 minus 1 is 3. And so we get 24 minus 3. But 24 minus 3 is 21. 1/3 of 21 is equal to 7. So the correct answer to problem 1 is 7. If we take a look at problem 2, we get f of x equals square root of x. And the interval here is 0 to 4. And so the average value of f is 1/4, right? Because 4 minus 0 is 4, times the integral from 0 to 4 of square root of x dx. So this is 1/4 times, we get 2/3 x to the 3 halves, evaluated from 0 up to 4. But 1/4 times 2/3 is equal to 1/6 times. And I'm going to plug 4 in for x to get 4 to the 3 halves. And if I plug 0 in for x, I get 0 to the 3 halves. Square root of 4 is 2. 2 cubed is 8, right? So this is equal to 8 over 6, right? So think about 4 to the 3 halves is just square root of 4 to the third, right? But this is 2 to the third, which is 8. So that's where I'm getting that from. And so the answer to problem 2 would be 4/3. Let's take a look at problem 3. Suppose g of x is 3 cosine x. And the interval is negative pi over 2 to pi over 2. So the average value of g is 1 over pi over 2 minus negative pi over 2 times the integral from negative pi over 2 to pi over 2 of 3 cosine x dx. But pi over 2 minus a negative pi over 2 is pi. So this is 1 over pi times. You're going to get 3 sine x evaluated from negative pi over 2 to pi over 2. So this is 1 over pi times 3 sine pi over 2 minus 3 sine of negative pi over 2. Now, sine of pi over 2 is 1. 1 times 3 is 3. So this is 1 over pi times 3 minus, now by the way, sine of negative pi over 2 is negative 1. So this is minus 3 times negative 1. So the answer here is 6 over pi. Let's take a look at problem 4. Suppose f of z is equal to, we get e to the 1 over z. Let's see if I could write that a little clearer here. We get e to the 1 over z divided by z squared. And the interval here is 1 to 4. Now, we're going to look at the average value of f, and that's 1 over 4 minus 1, b minus a, times the integral from 1 to 4 of e to the 1 over z divided by z squared, dz. So I would encourage a u substitution here. I would let u be 1 over z, and so du is negative 1 over z squared dz. And so negative 1 du is 1 over z squared dz. Now, when z is 1, u is 1, right? I plug that in here. And then when z is 4, u is 1 over 4. And so the average value is 1/3. And if you don't mind, I'm going to put a negative there. Why? Because that's what 1 over z squared dz is negative 1 du. So we're going to pull out a negative as well. And we're going to integrate from. Now, again, when z is 1, u is 1. So my lower limit is 1. My upper limit is 1/4. And I'm going to integrate e to the u du. But this is negative 1/3 times e to the u evaluated from 1 up to 1/4. So this is negative 1/3 times e to the 1/4 minus e, which is 1/3 times e minus e to the 1/4. So all I did was factor out a negative 1. And this would be the correct answer for problem number 4. If we take a look at problem 5, g of t is 9 over 1 plus t squared, and the interval here is 0 to 2. And so we're going to look at the average value of g, and that's 1 over 2 minus 0, right? Half times the integral from 0 to 2 of 9 over 1 plus t squared dt. But this is 1/2 times 9 arctangent of t, evaluated from 0 to 2. And so remember here, let me draw a little divider here. We want to remember that the derivative of arctangent of t is equal to 1 over 1 plus t squared. So that's going to come up a lot, so it's something we need to keep in mind. I'm going to pull that 9 out in front. And then if I put 2 in for t, I get arctangent of 2. And then if I put 0 in for t, I get arctangent of 0. And so the answer here is 9 arctangent of 2 divided by 2. And that's how we do problem 5. Let's take a look at problem 6. Suppose f of x is x squared over x cubed plus 3 to the second power. And my interval is -1 to 1. And I want the average value of f. And that's 1 over 1 minus -1 times the integral from -1 to 1 of x squared over x cubed plus 3 to the second dx. Now, I'm going to try something with you here. So 1 minus a -1 is 2, so we get 1/2 the integral from -1 to 1 of x squared over x cubed plus 3 to the second dx. So I'm going to let u be x cubed plus 3, u substitution. So du is 3x squared dx. So x squared dx is 1/3 du. So now, when x is -1, I'm going to plug that in here. U equals 2. When x is 1, 1 cubed is 1, 1 plus 3 is 4. You get u is 4. And so I get 1/3 times 1/2 times the integral from 2 to 4 of 1 over u squared du. Okay? 1/3 times 1/2 is a 1/6. So this is 1/6 the integral from 2 to 4 of 1 over u squared du, which is 1/6 times -1 over u evaluated from 2 to 4, which is 1/6 times -1/4 plus 1/2. So notice I plugged 4 in for u, 2 in for u, subtract, right? Now remember, 1/2 minus 1/4 is 1/4. And then I'm going to multiply by 1/6. And so the correct answer here would be 1 over 24. take a look at problem 7. Suppose h of x is cosine to the 4th x sine x. And my interval is from 0 to pi. And so the average value of h, I always write this way, is 1 over pi minus 0 times the integral from 0 to pi of the function cosine to the 4th x sine x dx. So I'm going to let u be cosine x. du is negative sine x dx. So sine x dx is negative 1 du. Okay? Now, when x is 0, u is 1, and when x is pi, I'm plugging up here, u is negative 1. So let's come over here, and this is negative 1 over pi times the integral from, I'm going to go from 1 to negative 1 of u to the 4th du. And this is negative 1 over pi times 1/5 u to the 5th from 1 up to negative 1. And so this is negative 1 over pi times negative 1/5 minus 1/5. And so the answer here will be 2 over 5 pi. That's number 7. And we just got one more for this video here. If we take a look at problem 8, h of u is natural log of u divided by u. The interval is 1 to 5. Okay? Now, the average value of h is 1 over 5 minus 1, b minus a, times the integral from 1 to 5 of natural log of u divided by u du. Now, we could, again, do a u substitution. That's fine. But we can't use u, so I'll use v. U's already taken up. So I'm going to let v be natural log of u. Because if you notice, dv is 1 over u du. So, when u is 1, v is natural log of 1, which is 0. When u is 5, v is natural log of 5. Okay? And so the average value of h is 1/4 the integral from 0 to natural log of 5 of v dv, which is 1/4 times 1/2 v squared evaluated from 0 to natural log of 5. But 1/4 times 1/2 is 1/8. So I'm going to plug natural log of 5 in for v. I get natural log of 5 squared, but I'm multiplying that by 1/8, right? And notice when you just plug 0 in for v, that's 0. So the correct answer for problem 8 would be 1/8 times the natural log of 5 squared. Okay, and that'll conclude this video for section 6.5. And we did the first 8 examples or the first 8 problems in the Stewart Calculus textbook. Okay, thank you.